Good afternoon, everybody. Thank you for taking some time today. I'm really excited about this topic, obviously, and recognize that I'm going to be saying a lot of things that sound very simple, but I recognize that it's actually very not simple. And it's been a passion of mine for many years. I'm very focused on workflow and automation and how do we actually identify the key things that we need to be getting done. And so that's really what the topic is going to be focused on, especially in an AI-driven world as we're seeing ourselves today. A little bit about me. I'm the founder and CTO of PlexTrac. I've been in cybersecurity about 20 years. Worn a lot of different hats in that time. I started my career in the Department of Defense, the US Department of Defense, and progressed into penetration testing, web application security testing, and then became a security director and then started PlexTrac. You can learn more about PlexTrac at our website, but really this is a topic that's very, that like I mentioned before, I'm very passionate about, and so eager to kind of share some of my learnings and also some of the things that I am eager to learn more from you all as well. So there will be a Q&A at the end, but I'm happy to take questions during the talk if there's anything that comes up. So really the agenda for today, really want to kind of discuss what is the problem around prioritization. What does that mean? How do we focus on it? And what are some practical approaches and needs to solving this problem? And what is the role of AI in not only in what we're testing and how it's impacting our world today, but also how do we potentially utilize AI in the prioritization process? And then how can we define an accurate view of risk using threat intelligence? And then how do we start to depict progress over time? So these are the main topics that I want to kind of discuss today and things that I've worked on in the past, and excited to kind of share my learnings, and really excited about the time together today. So I always like to kind of start out with the key question. You know, what problem are we truly trying to solve as we're in the security space? I'm sure we all have different roles. Some of us may be in the vulnerability management space or the pen testing space, or on the threat intelligence or the SOC side. But when we talk about reducing risk, what are the key areas that we're trying to improve, and how do we show that? So at the end of the day, I truly believe that we're always trying to show, hey, are we making progress? Right? Well, we're never going to truly be secure, right? There's never a panacea of like all the issues that we've identified are fixed and resolved, and there's no more issues to be identified, right? So really at the end of the day, we're all trying to just show that we're making progress, that we're getting better, that our security posture is improving, and we're identifying the key risks and working on the most important issues currently. We all have limited time, limited resources, limited budget, whereas the attackers and the threat actors, they're not as limited by those things, right? So we want to make sure that we're getting the biggest value out of the time that we're spending on fixing issues. So, and with that, does what we're focused on truly reduce risk in our environment? And I'll talk more about this later, but that really is meaning that is it context dependent, right? The risks and issues that get identified against one organization may not be as high of a priority for us, and vice versa. So how do we identify what is the context that's important in our environment? And generally speaking, I think that we live in an era where we're really good at sourcing data and information. We have lots of different vulnerability scanners, lots of different ways to identify risks, lots of different ways to identify threats and actors. We have lots of information at our fingertips, so we're really good at getting all this data together, or at least sourcing it, but we're not great at making sense of it all. How do we actually synthesize this down into what are the key things we should be working on? Are we working on the most important things? So these are what I really kind of want to dive into today, is how do we solve this problem? So first let's talk about like, what does it mean to be getting better? And truly it means, hey, have we identified the biggest risks in our environment? What are the biggest threats? Can we actually report on the progress that we're making over time? I think we're all probably aware that point-in-time statistics don't mean a whole lot. Like, we really want to be focused on trends and progress. Are the issues that are getting identified and the risks that are getting identified in our environment today Are they different from what we were focused on a year ago, and 2 years ago, and 3 years ago? And are we able to show, hey, as we continue to focus on testing these aspects and mitigating these risks, can we show that our security posture over time is improving? So that's really what we're trying to depict, is in terms of answering the question, are we getting better, right? It's not a matter of, hey, now this issue is gone and we don't have to worry about it anymore. It's also a matter of, hey, we continue to test to see if the mitigations that we put in place a while ago are still working, right? So you're able to show that progress from a year ago, we tested this, it didn't work. Now it is working, so in the positive direction. Or vice versa, right? Hey, we've tested this 10 times. For the longest time, it wasn't, it wasn't successful. Take a TTP, for example, of a threat actor. We tested this thing, it wasn't working, but all of a sudden it is working now. So what changed in our environment? So it can continue to help inform the prioritization process as well. But really what I'm trying to emphasize here is, do we have a way to depict the actual progress that we're making over time and not just point-in-time statistics? So how do we do that, right? I think this is we'll dive into this throughout the rest of the talk, but it really does require some key principles, and this is where I say this is not easy. This is a hard slide to actually implement, but I do think it's extremely valuable and important, because if you do this well, you actually can show demonstrable progress and more rapid improvement in your security posture. So I think the first and foremost, you have to have some form of centralized data where you can bring data together, aggregate, and normalize that. And so you're not having to poke at different systems to try and actually identify what are the key risks across these different systems. It's okay to have those, but do you have a way to centralize those? And from there, then you can actually centralize the process and workflow around it. Ideally, you want to automate as much as you can in this life cycle, but sometimes you just can't at this point, and sometimes that takes time and effort that you may not have or the resources to engineer it. But ideally, you can automate as much of the workflow around the prioritization, the mobilization, the assignment of issues, the tracking remediation of them, the actual work to patch or mitigate the risks. Regardless of what it is, ideally you can automate as much of that process as possible. But my suggestion is to start with the most prominent activities. So scanning, orchestration around your vulnerability identification, risk identification. Obviously with threat intelligence, you should be able to synthesize that in automatically. But then from there, being able to actually assign tickets to the owners, the triage, those types of things. I would assume that a lot of us have pieces of this from an automation perspective. So really trying to focus on what are the other pieces that we can automate, so that you can actually focus on getting some of the work done that does require manual effort. And then when we talk about risk prioritization, this is where it really becomes the context-dependent piece. And I think we'll spend some time here because I think this is super important. And I'll spend some time showing it in a couple of slides. But when we talk about risk prioritization, there's a lot of mechanisms to score your risks, right? And to be able to try to stack rank vulnerabilities or findings against each other. And I would say probably all of us have applied some form of subjectivity to that, right? The Nessus scanner or the threat actor report, identifies this issue as a very, very critical thing, but it really doesn't mean much for us, right? Or vice versa. It's not being reported as very low or as very high severity, but it really is important to us. And that could be based on a variety of variables, right? And so you want to be able to have a mechanism to apply some of that subjective nature to the findings and to the risks, but still being somewhat objective in that it's holistically applied across the board, so that you're not caught in this situation where it's like, hey, for the last year we were reporting this as a low, but all of a sudden now it's a high. Well, what changed? Like, why is that? So that you have some form of, you can apply the context to your environment, but you still have objectivity across all the issues that are getting reported. And we'll dive into that here in a second. But the other thing that I think is extremely challenging when we talk about this whole process, and the things that I've encountered in my career is truly identifying who owns the issues, right? Traditionally, security teams are responsible for tracking the risks, reporting the risks, but they really don't have as much ownership over the actual mitigation strategy, right? They can inform it, but if you're talking about a security vulnerability related to a web application or a system like in a network, typically the security team is not the team going and writing the code to fix the issue or deploying the patch, right? So truly having to identify a way to track ownership of this, and then being able to have a mechanism for reminding folks like, hey, it's you're kind of, it's taking too long to fix this, or what's the status. So having a way to track ownership of the issue and what role you play in that process is important. We'll talk a little bit about continuous evaluation and testing as well. This is all meant to be done in a continuous framework so that you are constantly identifying key risks in your environment. So this comes into factor from not only from vulnerability scanning, but from gathering threat intelligence and applying that context. That's where AI can really help, but also being able to show over time, like I mentioned before, when we're saying testing a process or testing, let's take a TTP, for example, from MITRE ATT&CK. You test this on a continuous basis, you can actually show when things might have changed, right? And so being able to do that in a continuous way not only continues to help stay current on the things that we've put in place in the past are continuing to work, we're continuing to work on new things, but if anything were to change, we would have a way to identify it. So that's a really important piece, and it helps everything else in the process come together. And then I'm very passionate about being a former pen tester. We always tried to identify, because you're tending to report on all the bad things that happen and all the areas where you do need to go get fixed. We would try to highlight exactly what security controls are working, right? The things that we tested that were working successfully, and being able to identify over time that list continues to grow, right? That's what you really want to show in terms of, are we getting better over time? Are we improving our security posture by implementing more security controls and validating that they're working? That really is the crux of the matter. So when we talk about data centralization, I did kind of want to highlight that this is in the context of the continuous threat exposure management lifecycle. You can learn more about this at Gartner. There's a lot of resources out there as well, just speaking about it. But I do think that it starts to bring the framework into play, right? And so being able to connect the key data sources, aggregate and normalize those across your environment. It does now support automation. It enables you to be able to do a lot of other things that you may not have been able to do in a point system. So if you're able to aggregate this data together in a central source, and you can start, like I mentioned before, starting with the key data sources is important, but there may be other, you may have a way to aggregate everything that in your environment, which is great, but definitely focusing on the critical processes for frameworks like CTEM. So if you're not familiar with CTEM, it's a continuous life cycle, and I do appreciate it because it really helps hone in, particularly on the prioritization when you're diagnosing the issues. And that's kind of the theme of the talk today, obviously, is how do we actually prioritize the most important things, but can we now show that we're starting to work on them and showing our progress? And that's really what I feel like the CTEM life cycle is starting to help us kind of grasp from a holistic perspective. But data centralization is very, very important in that regard. And there's lots of opportunities out there in the market or individually to be able to do this. But if you don't have a central place to be working from, it makes it a very much more challenging process, right? And introduces opportunity for error, right? So let's talk about like what I mean by prioritization and within the context of your organization. As I mentioned before, we need an objective measurement. So as findings and risks are reported, how do we actually know what their true severity or risk is within our environment? So how do we apply some form of subjective nature or context-driven approach to our environment so that, hey, every time this finding gets reported in, we understand the context that it plays in our environment. I would also caveat that this, I think I even mentioned it in a later slide, that this is an iterative approach. You can come up with a scoring equation or an algorithm to be able to score risks in your environment, and over time you may need to change that, and that's okay. The key factor is applying them holistically across your environment. So some of the problems that I've seen in the past related to risk scoring is a lot of folks will have it kind of be a black box, or you kind of end up trusting one vendor's opinion, but it's not really provided in the context of your environment. For example, a vulnerability scanner like Tenable may report, and they're going to report critical vulnerabilities for like a missing patch on all the systems that it identifies that, but it doesn't have the context of where those systems sit in your environment, whether they're in a lab or in an externally exposed DMZ. So how do you actually account for that when you're trying to actually prioritize, well, how do I know if I should patch this issue versus the other one? I know I need to patch both of them, right, at some point. But I'm only limited to time and resources. So which one do I know I should go patch first? And that's really what we're driving towards with this context-driven approach, is that it can lead to a better consistency across, like, hey, I understand why now I should go patch this system first because it meets the criteria that we've set forth. And then then it starts to inform the communication that it aligns to the business as well, right? Because I was in a talk earlier where you may have a system that is, you can't shut it down, right? You can't turn it off. Like there's certain factors that just play into the notion of we don't have the ability to really touch this system. So you have to put all the compensating controls around it, and that's how you're addressing the risk. You can build for that kind of context into your environment through an algorithm like this. This is an example of one where, similar to like a college syllabus or like a course syllabus, where you can weight different factors and you can assess like how the weighting works and what criteria applies to that equation. There's many other opportunities to do this and other ways to do this, but this is just kind of an example of I really do think this is a very, very important piece of being able to prioritize the right issues, because it provides some subjectivity that you need for your environment, but two, it's going to get applied holistically across your environment, so you do know that you have some of that objectivity available to you. So when we talk about like scoring algorithms and how we set up our scoring equations, I think that some of the key principles are making sure that it's consistent. Now, organizations are complex, right? Not every organization is the same, and this is why this is valuable. You may have different business units that have different goals, right? So you may have a manufacturing line that has a different goal than something else, right, in your environment. So you can apply, so I think what's important is like you can apply a different equation for those different types of business units, and this is just an example, but as long as the equation is consistent within the business unit, that's what's most important, because it maintains that objectivity within that business line. So that's why I say it's consistent. So you may have two different equations that you evaluate your risks by at an organizational level, but they're consistent within their line of business. I think it should be clear what constitutes the risks in the environment. For example, like this one, I think it's a little heavily weighted on asset. So like how many assets are included in this finding. For example, Tenable scanned it and hey, it found out of the 1,000 assets that it scanned, it found it in 99% of them. And then like what criticality the asset plays. So if you tag your assets with, hey, this is a piece, like if you're a PCI shop, hey, this is in the CDE or something like that. It assesses, it automatically that is going to have a higher weighting than say like a lab machine, right? So it provides some of that context, but it's clear as to how it's getting calculated, right? Because at the end of the day, we're always trying to appropriately communicate our risk. And you want to be able to say like, hey, this is why it got scored this way. I do believe, again, we mentioned comprehensiveness. Making sure that it's applied to everything that's getting reported is crucial. Objective in that you are able to remove yourselves from any singular issue that you know about, right, and can apply the context to the whole. Because I think even as a pen tester, I would manipulate the CVSS scores that I would report on tests all the time, because it's like, yeah, this calculation's not coming out the way I want it to. I know this is a bigger issue, so, so I'm just going to report it as a bigger CVSS score. And that's just the human nature of things. It's like, no, I know this is more important. So being able to provide some of that objectivity is important, because you don't want that then starts to destroy the value and the trust that you would have as you're starting to prioritize your risks. And it could lead to bigger issues in the future. And like, as I mentioned before, this can change, but you just need to make sure that it gets reapplied holistically across the board. So, and this may change the priorities of what you're working on today versus tomorrow. So now that we've actually been able to apply a context-driven scoring algorithm to our issues and risks, now we can actually get a better view of like, okay, I've got all these things reported. How do I know what I should be working on? And that's where this contextual score can really play a big factor. It can stack rank all the issues against each other, sort it, now you've got it, right? So now it's like, okay, well, let's go work on outdated malware protection, right? So we know that one looks like it's critical based on the factors that we put in place. So like if we know that, and we can communicate effectively, if we go start working on that first, it's going to reduce the risk to the environment. This also helps you communicate what threats should be you have that are concerning to you over others, and it really provides a justifiable focus. I think that what I've seen a lot is, and including myself, is like security teams have a hard time communicating. Well, this is why we're doing what we're doing. Like I mentioned, as a pen tester, I just know, I know this is an issue, but sometimes it's not always easy to communicate the why, and this helps bring that justifiable focus into light. But what's also important is that this is not a mechanism to necessarily say we're never going to do the things that are lower priority. It's just a matter of like, hey, we're going to start and focus on the ones that are highest priority, and then we will continue to work through the list. And this list will continue to change. And if environmental factors change, like we mentioned before, you can change the algorithm, and then the stack ranking may look different, but at least we have a way to communicate that effectively. So this is all well and good, but then how do we actually continue to start to focus on reporting this over time? This is an example of the MITRE attack matrix. It's a little dated, but I like the picture because it has the colors that I wanted to show. But moving from the reactive to the proactive is another important piece of this puzzle in terms of our prioritization and how we're identifying issues. But I also wanted to highlight that reporting on what's working is just as valuable as reporting on what isn't, because that's really where you start to get the delta or the difference between the elements that you've been fixing, and you can actually report on that progress over time. So it's important from my perspective to not just include the findings that are coming out of all of these assessments, or that you've got these threats in your these threats are posing potential risks and you've never tested for them, but saying like, hey, we're going to go test for these, and over time we'll be able to turn some of these reds into greens. And I think what something like this, and I'm not saying like this is the panacea for reporting progress. In fact, I think it has some, like this is a point in time, right? So, but what this can show you is that, hey, the reds mean the reds is actually okay in the sense that we've actually tested for it. The whites and the grays mean that we haven't actually provided any coverage there. So those are unknowns. Like we don't know if we have issues there. The greens imply that, hey, we have tested this over time and it's now in the green status, meaning we can detect it or we can prevent it. So the value of being proactive and saying these are the things we're going to test and we're going to continue to test them allows you to start showing your progress, not just from, hey, we had issues that we reduced and eliminated, But over time, we've also tested all these other things and shown the value that whatever investments we've made in security controls are working, right, and continue to improve. So in an example like this, the more green you can get to, the better you can show. However, I would still vote that you want to have a trending view of this type of data. So in terms of some of the proactive principles, this is where I really think that threat intelligence, I've got another slide here shortly, really can play a really important factor, not only in our defense, but in our offense. So as you can incorporate this into your testing plans, that's how you actually show in the previous slide, how do I know what I've been working on, right? How do I know what I've been testing? So as intelligence come in, say against certain threat actors, you can collaborate on the context within your environment. Is this something that really is a threat to us? For example, say a threat actor is really targeting healthcare institutions. We're not a healthcare institution. Maybe it doesn't apply to us as much. Or no, we are a healthcare institution. We have the exact same tech stack that this is working against. We should go ahead and test for it. Develop that test plan, and that test plan is crucial in that's what shows all the things that you're going to test and whether they're working or not. So from a TTP perspective, you actually can identify like, hey, we tested all these things, half of them worked, half of them didn't. We're going to go focus on the things that we weren't able to detect. So you execute the test plan, validate, measure, report, continue to repeat. So this is really moving from that reactive side into the proactive side, and it informs everything about your prioritization process moving forward. So now, kind of as I mentioned before, you're now able to highlight what is going well, what's going right, through it from a tracking or remediation perspective. You can highlight the coverage that you've had, which TTPs were evaluated, and over time, ideally, like this is like a purple context of our purple team, but similar notion to the TTP testing of like, hey, they were able to test these things and they didn't work, whereas the blue team was able to detect or alert them. So what you would call control validation, which is kind of a continuous validation. So again, it's a proactive assessment paradigm that continues to inform your prioritization process and removes you from the notion of always having to kind of wait for things to happen. You're actually able to show proactivity around, we're testing these things on a continuous basis. Over time, and here's how they've been prioritized from a risk perspective. We've worked on those risks, reduced the risk, and now can show progress in terms of these are the things we're always testing for. These are the new things. These are the issues that have resulted from it. We're reducing the risk from mitigating those, and the cycle continues to repeat itself. So ultimately, you want to be able to answer, like, how good are you at detecting threat and attacker behavior? Are you able to accommodate and adapt to new and emerging threats? So as a Log4j comes out or some new threat actor comes in and identifies new TTPs, can you build that into your process in a proactive way as opposed to waiting until signature detections come out or something like that? Or having to do the opposite, which is threat hunting. Like, I would still say threat hunting is a proactive capability, but it's definitely a reactive practice, right? In terms of, well, we're looking for these things. If we find it, that means something happened. As opposed to, let's go test for the gaps and be able to report that, hey, as this threat actor emerged, we were able to build this into our testing program, prioritizing the right things to reduce their risk and continue to also reduce recurrence. So as I mentioned before, we've tested these things 10 times over the last 5 years. It never became an issue, but all of a sudden now it popped up again. What happened what changed in our environment to identify that recurrence? But also it really does assist in reducing recurrence. So you start to identify, like, hey, I'll take SQL injection, for example. We were fixing SQL injection this way, and all of a sudden it just keeps coming up. We gotta revisit our approach to reducing or to eliminating SQL injection, and so then the recurrence is reducing. But if you're not testing for those types of things, you can't really identify why it's recurring. So let's talk about AI. So we're obviously in an AI-driven world these days. It's no secret that attackers and threat actors are using AI for their benefit, so we definitely should as well. How do we implement AI into this process? AI is really good at synthesizing large data sets. So, as we talked about in terms of centralizing the data, that does result in a lot of data, right? Depending on your environment, it could be quite large. And AI just so happens to be really good at making sense of these things, given that the model is trained correctly, and that those are different problems. But Adam Ashinsky, and I forget Mr. Donahue's first name, but they gave a really good talk at RSA this year. It was a tack on, or a second version of a talk that they had given in 2023 around training an open AI model to actually help identify what, based on a tech stack. Like, here's my tech stack. What threat actors actually, would target my tech stack, right? And so it was able to identify, hey, these are the TTPs that you really should be worried about, right? So go test for those. Really, really good talk, really good research, utilizing AI to help inform your process, right? Jason Haddix is another, great pioneer, I would say, in terms of research in AI, and he's got a red, blue, purple teaming AI training course that he just launched. But he has a lot of good resources as well around using AI from a proactive perspective. So being able to use AI to help in your pen testing exercises, identifying what are the key attack paths in your environment, which is really critical for not only you, but also for a pen tester. Like, if you can identify the key critical attack paths, breaking those chains, you're definitely going to reduce risk. So then, I'm really excited about what we have as the art of the possible within AI. So when we talk about having a centralized data set, now you can actually correlate the findings that continue to get reported, and being able to help contextualize, these are the ones we should be fixing, but also identifying why they keep coming up. Generating test plans, as I mentioned before. As threats come in, you could use AI to say, like, hey, we don't have any findings like this in our environment, but it's also because we've never tested for these TTPs or anything like this. So it can help you actually say, like, these are the things you should go test, because this is how they would emulate this attack in your environment. Now you're starting to be in the proactive continuous life cycle. Again, not saying this is easy, but these are the things that I'm really excited about what we can do with AI. You can obviously connect the threats to attack paths in your environment, and you can truly ask questions of your data. If you've got it centralized, AI is perfect for synthesizing large data sets and being able to make sense of things. So, hey, what are the most important findings? How should we be scoring our risk? Those kinds of things AI, I think, can really begin to help us with, and I think we'll see a lot of that in the time to come. So when we talk about threat intelligence as well, how do we utilize threat intelligence for not just, like I mentioned before, not just defense, but actually offense and proactivity, so mobilization. Threat intelligence traditionally informs defense, should inform offense as well. We've mentioned before, being able to identify what test plans should you go execute, being able to also be a weighting factor for your scoring mechanisms. So, for example, you can have a weighting category in your scoring mechanism to say, hey, is this being exploited in the wild? Is a threat actor, are these TTPs actually applicable to a threat actor? Then that may have a higher weighting for your prioritization. So the key questions regarding threat intelligence from a proactive perspective is, how would this threat work in our environment? Do I need to adjust any of my test plans that I'm doing on a consistent basis for this? Can I emulate their activities in different ways? So I think if you've worked within the attack matrix at all, you know that things around PowerShell and things like that are examples of the things that they did, but can you alter those to a degree and still get it to work, right? So that's what a pen tester tends to do, is, hey, I know this is going to get detected from a signature if I do this exact command prompt, but can I tweak it in any way or encode it in a different way, the payload or whatever, and get around it? So, being able to, this is another great question of AI. Can I manipulate this attack to to bypass any detections as well, right? So this all leads to the ability to actually remediate. This is where artificial intelligence and threat intelligence can really help in your remediation operations as well. So not only being able to identify the key priority, but actually being able to help automate where it can. So I do believe that AI is going to be able to help us suggest these are the things you should go do, and would you like us to go do that for you? I do believe products are going to start coming out that can offer that kind of capability. I'm not a huge fan of trusting it without validating it, right? So I like the approach of suggested remediation plans, and then allowing the analyst or the engineers to actually go execute them. But anywhere you can automate, especially with the use of AI, this is going to be a great assistance to us as defenders. And then obviously we mentioned before, being able to assign ownership and track their progress over time is crucial. This is how you actually show where you start to get telemetry on where the bottlenecks are in your processes. So as you have telemetry on, hey, we identified this issue on this date. It took 20 minutes to identify who should be assigned to, and with the remediation plan, and then it got stuck in this other process that we don't have a lot of visibility into. But now you have telemetry on being able to actually report on our average time in this phase of the life cycle is 2 weeks, and our goal is to really reduce that down to a week. How can we work to better across our organization to reduce that, and where are the bottlenecks there? So truly enables deeper visibility on everything around your reporting process, which allows you to actually have better stakeholder conversations on reporting your progress. So as I mentioned before, CTEM is really a framework for continuous improvement. So being able to identify the trends, and if you can marry AI, TI, and continuous testing, you really will see demonstrable results. And I would say even if you can't do anything around AI or TI, definitely continuous testing is a big factor, right? So the more you can get into a continuous paradigm, you will see a drastic risk reduction within the context of your environment. That I know to be true because I've seen it. So we'll save a few minutes for questions, but just wanted to kind of highlight some of the key takeaways from today. Centralized data and ideally centralizing your workflows and processes is really critical to this. Being able to operate in a continuous testing and evaluation is pretty critical. Being able to apply a contextualized risk score, so it's objective but also subjective in your environment, allows for deeper accuracy and better communication. Threat-informed pen testing or testing in general continues to enhance your proactive story. AI can definitely help correlate large data sets and even potentially help you automate your capabilities. And in terms of reporting on your risk posture, focus on reporting on what's going right, not just what's going wrong. So thank you very much. Appreciate it. Happy to take any questions or answer anything that might be on your minds. So. Question here.
So you talk about a few places where AI can help automate the whole process. Can you give some examples on what places it's better to use AI to automate? Or maybe what are the places where it can help the most by using AI?
Yeah, I'm biased in this nature, right? But I believe that AI does a great job of actually identifying what you should be testing, right? So some of the research that I kind of highlighted, like Haddix and some others, of being able to truly identify, you give it parameters of your environment and your tech stack, and it can highlight these are the attack paths that I as an AI bot, I would go and be able to penetrate your environment, exploit it as deeply as it possibly could. I think that's a really good place to start from an AI perspective. again, it's a proactive approach. It does a really good job of identifying, correlating data on the reactive side. If you have like SIM data and stuff like that, being able to highlight, it can correlate events really well, right? But from my perspective, in the context of this, being able to identify the key attack paths and test, and then generating test plans for you to go test those things on a consistent basis is where that would be my advice for where it's really powerful as a start. Yeah.
So I don't know that we really touched on it here, but I'm kind of curious your thoughts, thinking, or exposure. Context. I have just lost track. I work with so many different companies that when it comes to their CMDB, their current as-is state network architecture, application architecture, how all the pieces are together. What I would say is the critical components to establishing the context. 90% of the companies out there, it's a dumpster fire. To what degree or where might there be opportunity for maturing AI capability to streamline the ability to get there, short of having to ask C-levels, hey, do you have a spare $5 million because we need to clean up your CMDB?
Right. Yeah. No, I think you bring up a good point. Is like people's data sets are usually in a disarray. Yeah. So that is a great application for AI in that, like, similar to what I mentioned here, is it can help correlate, like, these are the vulnerabilities we know might exist in this attack path. So, and it can also say, like, hey, this is an exposure from something internet facing or not. So I do believe that AI can help in synthesizing these are the assets that it feels are most critical in the attack chain, where you didn't have to go and tag everyone or clean up, add additional rows and context within the data set to be able to apply the scoring, right? So I do think that would be a great application to start of, hey, if you can apply the data set, overlay that with AI and be able to get a model on top of it that can say, like, what are the key vulnerabilities that we have here? That's going to help, and even automate the tagging and potentially aspects as well. But you're absolutely right in that the data sets are in a disarray. If you can centralize those or have a way to centralize those and then be able to throw AI on top of it, I do think that there are actually ways where it can actually help in not only identifying the key critical assets or attack paths, but potentially even can help synthesize what other characteristics of your assets and vulnerabilities are worth tagging and being able to suggest things like that. So, for example, I keep coming back to the attack path of, within the attack chain of, hey, I've identified that this is an externally facing asset, but it's also connected via user accounts and API calls to some internal systems that house other sensitive information. It can synthesize that pretty well without you having to have said that this is a DMZ asset and this is a internal HR asset or something like that. So I don't know if that's helpful, but. Great. Well, thank you so much. Appreciate your time. I'll be up here for a few minutes during the break and happy to answer any other questions. But thanks and have a great rest of your day and a great rest of your conference.